straw and a plastic bottle. Start off by rubbing the straw on a piece of cloth and then balancing it on the top of the bottle. And what you'll find is that just by placing your finger anywhere near the end of the straw, you'll be able to move it around. To make a rocket out of a tea bag, all you need to do is take a tea bag like this, cut off the end and then empty out the tea, and that will leave you with a cylinder of paper. Stand the cylinder of paper upright and then carefully light the top of it. As it burns down, eventually at some point the rocket will launch. Place the tips of your first fingers together like this, around about 6 inches from your nose, and then focus on an object in the distance. What you'll find is that your fingers appear to transform into a small sausage, and just by separating them, that sausage will appear to float in mid-air. This involves a pencil, a heavy object like a vase, a piece of string, and a feather. Attach the vase to one end of the string and the feather to the other, and then suspend the vase over the pencil. And when you let go of the feather, it wraps around the pencil, breaking the fall of the vase, ensuring the vase is perfectly safe.
Alright guys, so that was something just fun just to kind of check out. I always like watching those videos. There's kind of neat little tricks that you can do, and it's like a lot of different things that you wouldn't think would happen, but they end up actually working out. So, hello there. Let me just set my camera up here. We'll get things going for today. There we go. We're all set. Alrighty. So today we are going to be taking a look at writing and solving compound inequalities. Now you guys have done this before, so this is not something new for you, okay? But before we take a look at it, we have to first discuss, hang on one second, pencil just broke. Be right back. And we're back. Okay, so compare and contrast inequality versus equation. When do we use open circle, closed circle? An equation is something that has an equal sign, okay? So that's what makes an equation. I mean, you've been dealing with this since Algebra 1. I mean, for as long as you can remember, an equation just has an equal sign. In equality, you have some options. 2x plus 3, here's an example of less than 7, all right? Now, less than, right, is just a symbol that we can have. We have less than, greater than. These would be open circle. Okay, like when I ask when you use an open circle, closed circle, that's meaning that you're not including it. So if I was to solve that, I get 2x is greater than 7. Oops, when I subtract the 3 over, I get 4. Divide by 2, x is greater than 2. So it's anything bigger than 2, but not including it. Meanwhile, if I had this equation, 2x plus 3 is greater than or equal to 7. Now when you solve it, you're including 2 in your solution set. Okay? Here's the big difference between inequalities versus equations. Inequalities, you have a solution or a set of solutions, meaning that you can have more than one answer. Any answer over here for this one, bigger than or equal to 2, will work for this equation. Anything less than it will not work. Okay? So, in words, here is our less than symbol. Here is less than or equal to. Here is equal. Here is not equal to. Here is greater than. And here is greater than or equal to. Okay. As far as examples go, you can have stuff like this where you have like x is less than 2, meaning anything less than 2 will work for that solution set. X is less than or equal to 2. You're going to see being seeing 2 a lot, one of my favorite numbers. That just means it's included in your solution set. X equals 2, meaning that's the only solution for that problem. X does not equal 2, meaning that it will not work for a problem. X is greater than 2, meaning anything bigger than 2. And lastly, greater than or equal to 2, meaning anything that's larger than 2, including it. So a compound inequality contains 2 or more inequalities. And the and, usually written as one statement when using symbols. X is less than 5 and x is greater than negative 2. Okay. What that means is you're going to sometimes see it written either as this or you'll see it written like this where x is in the middle. Okay? The best way I can say is, okay, so this is read as x is greater than -2 and less than 5. So when x is in the middle, that means it's everything right here. Notice that was less than, so it's open circles. But your solution set is the numbers in between here. Nice easy way to check too is say 2. 2 is located between them. If I put 2 up here, is 2 greater than -2? Sure. Is 2 less than 5? Absolutely. So it works. You pick anything over here like 10. Is 10 greater than -2? Absolutely. But is 10 less than 5? No. All right, so you can kind of see how it works and contrast everything. The other big one, and's our first one, the other one is or. Or will always have the word or in the statement. X is less than or equal to -1, or x is greater than or equal to 2. This is read as we just said that. The graph of an compound inequality will have two pieces which should go in opposite directions from each point. So if we were to graph this, here's my -1. Less than or equal to is a closed circle. Everything less than it. 2 is a closed circle as well because it's greater than or equal to. And it's everything to the right. Okay? I know some of you guys are asking in class, like, how do you know which way the direction goes? I know we taught this little trick. If you have x on the left-hand side, it tells you, the arrow tells you where to go. This one's pointing to the left. Meanwhile, over here, as long as x is on the left, this arrow is pointing to the right. Okay? So it's a nice, easy, quick way to help you out there. Okay. Oh, and once you know it, we have our graph right here, all's well. When solving compound inequalities, whatever you do to one piece of the inequality, you have to do to all pieces. Your goal is to isolate the variable between the inequality symbols if there is more than one. So I'm going to go, there's a few examples here. It says you must flip the inequality symbols if you multiply or divide by a negative number. That's the one I want to stress to you guys because it's the one that's unique to inequalities. So here's an example using addition. -3 is less than or equal to -4 plus x, which is less than or equal to 2. You can add 4 to all three sides. Okay? Boom, boom, boom. -3 plus 4 gives you 1. -4 plus 4 cancel it out, leaving me with x right there. 2 plus 4 gives me 6. Notice that I'm just bringing down the less than or equal to signs. Just bring them straight down. So my graph for this, okay, it's in the middle. So I've got 1, I've got 6. They're closed circles. It's everything in the middle, okay? So what I'd like you guys to do, all right, is to come up with something for your own example. So for example, how many times can I say example? How about 3x minus 4? Now I'll make it even easier than this. We'll just go x minus 4 is less than 6. Okay, so there's your example. Now, what do I have to do to both sides? I have to add it to both sides. So x is less than 10. Okay, so if I set up my graph at 10, open circle, everything to the left. Alrighty. Now, the thing I want to point out to you guys is down here for multiplication. These ones right here, using subtraction, using division, and mixture of properties. I'd like you to come up with your own graph, considering they're giving you the answers, not too bad. And I'd like you to try to come up with your own example, okay? Like, you know, something that involves subtracting both sides, something that involves dividing both sides, something that involves mixture of all. But here for multiplication, see how it's -1/4 x is greater than 2? In order to get rid of my denominator of 4, I have to multiply both sides by -4. In doing so, I get x, but look what happens at an equality sign. It was greater, it flips to less than. This is unique to compound inequalities, or inequalities in general. So my graph for this one looks like -8, open circle, everything to the left. So where can I see an example of this? Let's go with -1/3. X is less than or equal to 6. You can multiply both sides by -3. X is greater than or equal to -18. Okay, because the inequality sign flips. There you go. All right. Taking a look at the very bottom then. Okay. Graph the solutions from the My Example column above. That's your own. You can try them out. Let's see here. I know it's kind of got cut off here, so I'll bring this down. There we go. A baseball team has $1,000 to spend on supplies. The team spent $185 on a new bat. New baseballs cost $4 each. The inequality 185 plus 4B is less than or equal to 1,000 can be used to determine the number of new baseballs B the team can purchase. Which statement about the number of new baseballs we purchase is true? All right. So using this information, go ahead and see if you can solve this out. Okay. Once you guys finish this up, we'll take a look at it together. Again, keep up the good work. Hope you guys are working hard on this. And as always, good luck. We're all counting on you.